Rīga, Svezzinati. The title of this talk means when you have a math module and a database, can you use that to make a faster math module? My name is Martin Becker. I come from South Germany and have studied math at one time in my life. And now it's spare time. I write computer algebra systems, and some of that is on CPAN or scheduled to go to CPAN very soon now. And I also have an anniversary of being on Perl events, and I'm very fond of that. So thank you for coming. We will look at a couple of examples, what kind of data you might want to package together with your distribution after having computed it in advance. First example are prime numbers. Prime numbers are needed in many algorithms. Some algorithms need prime numbers, all of them beginning with the smallest one as a long stream of numbers. Other algorithms need medium-sized random prime numbers. And, well, you might want to have those in a package and in your distribution. No, that's not such a good idea. Why not? For one thing, there are just too many of them. It would make a very large file to ship with your distribution, and it wouldn't, you wouldn't gain much because small prime numbers are easily generated. So yes, you reuse them in your runtime after generating it at runtime. It makes no sense to store them in a file. For medium or sized prime numbers, this also makes no sense because, for example, if you need random numbers, there wouldn't be any random any longer. So that's not an example for what I'm talking mainly about now. Prime numbers, checked. One thing with prime numbers is factorizations. You probably remember from school that every positive integer has a unique factorization. That is the prime numbers that multiply together make up the number. And for present technology, it's not easy to find factorizations. So if you have special interest in certain factorizations, some algorithms need them, it makes very much sense to compute them in advance and put them in a package. Of course, you can't do this for all numbers. It only makes sense if you have a small set of numbers that are of interest for sheer size. A factorization could look like this. You have a list of pairs of numbers, a prime number and an exponent, and the list is of variable length. And simple, you could simply store this in your program text. But why is that not such a good idea? It takes 3 times the space. First in your source file and the things your maintainer has to read. Then in the executable, in what Perl has to execute, and of course in your runtime memory, random access memory, which is very precious, although you only need read-only data. So our first step would be to extract this data and put it in a separate file. You can also make it a bit more terse. You don't need Perl syntax, just characters that separate them, something you can pass back again into a Perl construct. And we don't need exponents 1, for example. So with that, with a separate file for our data, I skip over this, we still have RAM, random access memory, we're wasting. So what else could we do? Now, there's one approach is to use Berkeley DB. Berkeley DB is a library, a C library, that puts data in files, and you can use it as a simple database. And Perl has had support for this since the beginning. It was a DB_file module. Now the current successor of this is Berkeley DB, and it allows you to access the data in your file like it would be in a variable. So you still have a hash with your index of things to access, and with the type function, you tell the Berkeley DB class that it has to populate this when you need it. And for producing the file in the first place, you can use the same interface. Just not rather than read only, you tell it you want to create something. It's very easy to use, has a couple of advantages. Of course, we have in our case still not structured data, but strings that need a little bit parsing at runtime to be converted back into data. But Berkeley DB is quite useful for this. A disadvantage is that there are tons of versions of this library, and you can't know in advance what your target platform has installed. So it's a good practice to package actually a text file and generate the database at its install time. So whatever database version your user has will be populated with your data. And the Berkeley DB Perl module is able to do this in a transparent way. Now, other sorts of data we might want to store. There are polynomials, for example. Data-wise, a polynomial is just another list of numbers. In this case, we want, in the context of computer algebra systems, we want a certain type of polynomial. If different systems use the same polynomials, they are better interoperable than if you take a random polynomial. These polynomials are sort of a standard, so it makes sense to package them. I skip over how we implement this, and I also skip over logarithms to come at something a little bit more interesting, perhaps. When our data has more structure to it, we can use other database techniques. For example, relational databases are able to model quite complex data. And in this example, we are not really complex, but just as an example for something we could do with relational database, we have as an object something with a couple of attributes, our set, and it has a variable number of elements. And this is a 1-to-n relation we could model in a relational database. For example, like this. This is an element of the set, and several of these elements belong to one set object. So we can do much more than this. We could have many relations in a database, but of course we need a suitable database. And luckily there are solutions that, for example, don't need a separate server, don't need much more than a C library that can come packaged with a Perl module. Though you have to be aware that this puts a little strain on your dependencies. The user has to install more in order to make your program run, expecting that it does just math. He suddenly is confronted with database software. But this is what we want to take advantage of. And if there are already modules for it, as I will show you, it's not that hard to do. So I skip over some optimizations, perhaps except this one. If you have a long string of ordered integer numbers, you can make this much shorter with the same information if you store the differences rather than the origin numbers. But these are implementation details. What I also wanted to ask here is how can you store that data so that it is not a burden for the administration, that you find it reliably on all sorts of platforms. And first of all, we want it separate, separate from the Perl code. It's always a good thing to separate read-only data from the Perl code. It might have a different ecosystem to live in, but you want to install it somewhere where you can find it when you read it, need it at runtime. And ideally, you can also find it when you need it before it is installed at the time your installation tests run. And we have models for all that. There's, for example, file share here. The maintainer of file share here is here on the conference, but not in the room. Jens Resak. This will take care of where your model is. It is dependent on your distribution. You tell it what your distribution is, and it knows then where on this platform where it runs, the share directory where it is installed should be. In my case, I wanted to read in that directory because I wanted to be able to have multiple databases. Some databases that come from an extension and some that come with a base module. The complement of this, finding the data, is depositing the data somewhere. I forgot. File share here has one disadvantage. It finds the data where it ought to be installed. So at the time you run your pre-installation tests, it's not already there. Those can't use it. And another replacement of this is file share. It also offers a method distdir that has the additional function that it detects whether it is in a build environment, and in that case gives you the directory where your build is putting the data. So with file share, as the provider of the place, of the location where to look, your tests will function even before it is installed. Now, the complement, the other side, where to put. You need a little bit of boilerplate and the module file share the install in your makefile.pl. So that it is arranged for that at install time, your data is copied from the local share directory to wherever the platform wants shared directories to be. And don't forget to mention it as a dependency, because in order to run your makefile, PL, you already need to have this installed. The toolchain will do the rest for you if you correctly configure your requirements. Now, so far so good. We have a place to put our bulk data. We have a mechanism to find it at runtime. Some considerations are still in order. How large should a distribution get? Nowadays, a couple of megabytes seems okay. Everybody should have that much spare storage for your module. A couple of gigabytes would not seem okay. Especially in the light of that CPAN is mirrored, thank you, thousands of times. And this would not scale very well if you bloat this with your bulk data. And the same holds for the target system. A user that only looks at your module to see what it does, how it is documented, and so on, probably will want to opt in to actually install gigabytes of data. So with my modules, I put a small database with a base module, having all the functionality, but not all the data you ever might want, and provide a way to install the rest for those that really need it. And a look at some existing distributions. For example, CPAN, not counting Perl's. Perl distribution ought to be a bit large-ish. Shows that I didn't make the top 10, but rank in 277 in size with my module. And in this list, there are actually modules that come with big databases. For example, for the results of language measurements for those language modules, and others that wouldn't need to be such big. For example, they can have an abundance of test data, and you should design your tests so they don't need such huge data. For example, if you have something that can stream video, you don't need to package for your tests a big video. You could package a small video. Or some of the top 10 modules have even relics of debugging that ought not to be in a distribution at all. When I found it, I immediately filed a bug. So all in all, it's good to be nice to people, nice to your users that need that bulk data, and on the other hand, to the millions of CPAN users that don't need it, or the thousands of CPAN testers that want to do reasonable tests. So this is my conclusion. It's good not to waste CPU cycles by repeating the same calculations over and over. But there's a limit to what you should do with space, and you should also be space efficient if possible. Thank you so far. Are there questions and comments? Yes?
With the storing of the concatenated integers, do you have to store a seed, right, for each of the deltas?
Yes?
Yeah.
The question was, if I took it right, when I store numbers in a string as decimal numbers, if I was that the question? At some point, we could package numbers in, say, 64-bit integers and use PEC or blobs And in my example, there was a text file, a text record, and this was an advantage because I have many numbers in my set, and when they are sorted, there is much redundancy. You could optimize. Does it answer your question? Yes. Any more questions? So, thank you for listening. Thank you for coming.